All right, let's go. Are you guys ready? Nice. Okay. So yeah, today we're gonna do FHE smart contracts on FEVM. It's a very terrifying title, but no worries, we're gonna understand what it means. And for first, I'm gonna explain who am I, so you won't trust some stranger. So my name is Aurora Poppyseed. That's how I like to call myself in this Web3 world. I'm a DevRel at Zama, and I call myself a hackathon expert, although, I'm not, but, I like to call myself that. And I've been in blockchain since 2022. A few years ago, they told me I'm just a new beginner and that, oh, you're a newbie. And now they call me a veteran already. So apparently I'm a veteran. I don't know if this is true or not, but there's so much things happening in the space that in such a short amount of time, so many things happen. All right, so let's look at what we're going to talk about here. So first, we're going to introduce the problem. So problem is that blockchain fails at confidentiality. I'm going to try to convince you this is true. Then we're going to look at the solution. How do we construct a system where we can compute encrypted data? Then we're looking at the result. So once this is going to happen, what is the result? So the result is that our tokens that we all know, the ERC20s, can become confidential and you can use them. All right, so let's look at the problem. So the problem is that blockchain fails at confidentiality. But what is confidentiality, right? We talk about a lot of times this interchange. We say confidentiality, privacy, confidentiality, privacy. And I'm going to be annoying here. Why am I talking about this? Because it's an important concept that you know. Once you know what confidentiality is, you know that it's a very missing piece in today's world and today's society. And because we don't have it, the adoption of blockchain is kind of not there yet, right? So what is confidentiality? Well, confidentiality is obligation of those who manage information. So basically banks, let's say medical providers, let's say, I don't know, legal lawyers, right? So this is the obligation of those who manage the information. Then we have the rights of individuals, and the interchange in between is basically our managing and protecting of sensitive information. All right. So what's the problem with blockchains? What's the problem with Ethereum? Well, all the data that we see there is basically exposed. We can see here, there's a lovely little family sitting at the table, and you can immediately see who is the boss, right? Who is the boss? The one who has the most amount of money. Well, this is okay. You can say, okay, whatever. Everybody knows how much money we make. That's not a problem, right? But also what can happen is we can have a hacker, and this hacker is going to target you. He's going to see your identity and target you. Give me your money at gunpoint, right? So we don't really want that, right? So our end goal would be that this hacker walks away sad and our family is left alone and everybody can enjoy their dinner. All right. So hopefully you now agree with me. Blockchain is not private. Everything, you can see everything. And we need a solution, okay? So we have we need to basically compute encrypted data on chain. And how are we going to do this? So we need to have some sort of way to have on-chain data that is encrypted. So for that, we need a universal key. what is a universal key? So universal key is a key that unlocks any chest. You can see in the pop culture, there's basically this idea of this mythical key that can unlock any chest. So this key would need to be there to unlock our information. So we have 1.2 million. We would want to basically put it in a chest, lock it away, and this would be the result. So hexadecimal number that we can store it anywhere. And only this would be exposed. So where can we store this key, right? Can we store it on the blockchain? Well, it won't work, right? A blockchain, as we know, it's basically a bunch of nodes, so a bunch of computers. So if we were to store it there, you would make our hacker like a very easy time, because each node would then have its own key, right? So that wouldn't work. All right. How about if we would have a server? So you can call it keys for those who know about this, that is basically connected to the blockchain. So this would be an off-chain server connected to the blockchain. Right, then you can ask yourself, well, who has access to this key? Well, the manufacturer has access to the key, the person who has the server has access to the key, and well, the hacker can target this one server and can basically, if it's not managed properly, can get access to the universal key. So what would be the solution? Well, the solution would be, basically, our lovely cryptographers have found out that we can take the key, split it up into multiple different parts, and put this information on different computers that collaborate together and are connected to the blockchain. So this is the blockchain, and this is some process happening off-chain. And these computers have to collaborate together to construct this universal key that helps decrypt this information. And of course, our hacker is sad. Okay. So I'm going to answer all questions at the end. I'll come to everything, no worries. We'll have a answering question in the end, no worries. So, okay, great. Now our data is now secure. But what happens when we need to compute something? When we need to take something from some user and give it to another user? So, okay, I have my information, it's stored, it's encrypted, it's on chain, but now I want to send you some money. So we go back to our dinner table. The person here wants to send some money to another family member. So they want to send, I don't know, let's say $20, go grab some lunch. But how can he do this? So we don't know his number. So his number is basically encrypted. And what's basically happening behind the scenes, when I give you 1K, well, your balance increases for 1K. So there is some addition, right? So basically we say this is something that needs to happen. So some sort of computation needs to happen. What originally we would do, we would decrypt this information, do the computation, and then encrypt it again. So that is not secure, Barry, right? Somebody would need to see the information anyways, and it wouldn't make sense. So what do? We have fully homomorphic encryption that comes to the rescue. So fully homomorphic encryption is basically a cryptographic primitive that can help us with that can do computations on encrypted data. So how it kind of works behind the scenes, as you know from wallets, we have a public key, private key. You're very familiar with that. Always public key is visible to everybody. Private key is secure only to you. And then we have in FHE, we have a third key, which is called an evaluation key. And with this evaluation key, it allows us to do computations on this data. So what happens is we have an encrypted number and a second encrypted number, and the output is an encrypted number. So for example, encrypted 2 plus an encrypted 2 would result in an encrypted 4. Everything is just hashes, okay? All right. So at Zama, what do? We basically use this technology, and what I showed you in the, before, a few slides ago, here, basically, but in a much more complicated way, architecturally, to build confidential applications on any sort of blockchain. So currently we are available on testnet and will be basically by the end of the year available on Ethereum mainnet and then on other EVM compatible chains and of course Solana next. So Sepolia ETH testnet is available today. All right, let's look at the result. What comes from this monstrosity of architecture? Well, we can have our familiar ERC20 token. Okay, so basically we can have, so what we did, we partnered with OpenZeppelin that has the standard ERC20 contracts, and we made our own new standard, which is the ERC7984. So what happens now, the normal tokens that you are all familiar with, that so many different applications have been built from this, become ERC7984's confidential tokens. All right. So how would this look like? This is how you construct an ERC20 token. So we are importing ERC20s from OpenZeppelin contracts, token ERC20, ERC20 so on. Then we have in the constructor, we mint an initial supply, and we create a token conveniently named gold. And then we mint this, so we call this function mint, and we mint in the initial supply to message.sender. How would it look like creating ERC7984 token? Well, very similarly. So we also are minting the initial supply. However, we are using our FHE Solidity library. So we are importing the FHE from FHE VM Solidity library FHE.sol. We are importing the configurations. So here we have configurations for Sepolia. So each on-chain would have its own configurations. So we are importing this a similar way as is done here, import ERC20 from OpenZeppelin contracts. We are importing the confidential fungible token. This will actually be renamed to ERC7984. We are putting the initial supply, creating the token, then minting to the message.sender. We are converting this initial supply into a compatible type, and we have our own confidential token. So how would the output look like? Okay, so we have a gold token, and if we call balance of Alice, we would get this. So 20 to the power of 10 to the power of 18 would result in 20 ETH, right? Now, however, if we would call gold token confidential balance of, so this would be a confidential gold token, this is a normal token, we would get a result, something like that, a very long hexadecimal, that only Alice and nobody else could decrypt, and it would result in 20 ETH. All right, how about if we want to make something else? Well, we have tons of different possibilities. So we mentioned like, okay, we can do tokens. So we have confidential token. We have blind auction. So bidding on like houses, for example, if you imagine when you want to buy a house, you get a house. And well, the result from that is, well, if you've been on the private markets anytime, is really hard because you're just basically guessing what kind of the price could be, and you are hoping that your bid is the one that is correct. You can have privacy on-chain games. You can have confidential votes, encrypted DIDs, private transfers for banking, and so on. So all these different applications, if you want to build, you would use our FHE EVM Solidity library and basically call FHE.allow this, and you would have encrypted. So you would have like encrypted data types. For example, if you would want to do some computation, you would call FHE.add, balances message to sender, and amount, right? So different encrypted types as you're used to. You have integers that are basically very familiar to you. So you have uint8 would become euint8, euint16, and so on, and others. All right, let's look at some resources that you could guys use basically to do this. So I mentioned already the OpenZemplin confidential contracts. If you're building any sort of confidential token or something like that, you can use this as a resource. Then we have docs.zama.ai. The best one I like from here is examples. Examples will show you basically different applications that you can use already today. Then you have github.com FHE EVM React template, which would be a really nice template to start off from if you are participating in this hackathon, because you have some sort of... So two things that you need to do when you're doing FHE. You need to encrypt something and you need to decrypt something. So the encryption is handled by this library here as well. All right, and then I will strongly invite you, even if you basically don't win anything, or if you win something or anything like that, we have Zama AI developer program, which you guys can join. And we offer each month many prizes to best projects on that are building on top of Zama. So I think this time is like 10K prizes for the developer program, and then additional 10K for the bounty program. So bounty program has more specific applications, and then we have more like general applications for the developer program. I think it's now like 2K each or something like that. Oh yeah, and we have also like the golden ticket for DevConnect. All right, this is it. If you have any questions, don't hesitate to ask.